So, we're looking for Thomas, but I nearly ready. So shall we start? Dear friends, dear guests, dear colleagues, ladies and gentlemen, a pleasure to welcome you all. By the way, I'm Daria Parkhomenko, I'm the founder of Laboratoria Art&Science, and I'm also the curator of the New Elements exhibition that we've been talking so much about in the past two sections. I'm delighted to welcome you. And it's a hybrid event, so we are broadcasting on YouTube as well. We are so happy to have you with us, virtually or physically. Physically, we're meeting at the new Tratikov Gallery. Let me actually introduce the distinguished panelists that we have for our third session called Computing with Nature or Material Computations. First and foremost, I want to welcome my co-curator, Dietmar Offenhuber. Thank you very much.
So we are
Hello.
here in Moscow welcoming you to join us.
Также с нами сейчас в онлайн, я вижу, уже вышла Тереза Шуберт. Тереза.
Also online with us, we have Theresa Schubert. Hello, Theresa.
Regards from Moscow. So great that you are with us.
Hi, pleasure to be here.
Yes, Teresa is an artist and also participant of New Element show. And я забыла, на каком языке я говорю, извините. Мы вместе с Терезой создали новую работу, которую вы сейчас видите.
So together with Teresa, we have produced Ooze, which is an unbelievable installation. So some of you must have already been to the exhibition and seen it, and if you haven't for some reason, please note he has been extended by 1 month until late March, so you can actually come and be inspired. And we are also lucky to have Ivana Abramovic with us. Ivana is a quantum physicist working at MIT. She's actually working on tokamak, the stuff of my dreams. I actually think that tokamak is one of the most spectacular achievements of science and technology. And Ivana has been interested in computation since early childhood. So she's a very important participant in this session. Do you see us, Ivana? And also with us, and actually already on the stage, we have Mikhail Kurtov, who actually came here from St. Petersburg for this particular event. He's a philosopher and he's actually a media theoretician. He has authored several books, including one called Between Daydream and Fantasy. And one other book is called On the Theology of Code. And he's going to moderate this discussion together with Dietmar. And I'm also very happy. And I, particularly appreciate in times of the pandemic that we have coming specially for this symposium, all the way from Germany, Thomas Feuerstein and Ralf Baecker. We have had the privilege and the pleasure of working with these artists for many years. And I personally appreciate it very much. And it's indeed extremely precious for the laboratory, that we can actually continue this cultural exchanges. And please note, this is not the final session. There will be, a culmination of the whole day after session 3. But this is session 3 nonetheless. And you must have noticed that we've already discussed lots of different things, such as photography and so many others. But now we are going to focus on material computation. And after that, we shall have this incredible audio-visual electrical performance. You are going to hear the heartbeat of liquid metal. Actually, a garden mosk-inspired experiment, I guess, will probably not make your blood curl, but will keep you quite anxious. And I'm about to hand it over to Dietmar and Mikhail. Thank you very much.
Yeah, thank you. Thank you, Daria. And again, it's a great pleasure to be at least virtually with you from Boston, to share the stage with Daria, a great artist, Ralf Baecker, Theresa, and Thomas, and Ivana, and also a great pleasure to moderate this panel together with Mikhail Kurtov, a great philosopher and media theorist. So just a few words about this panel. So earlier we spoke about glaciers as computers, and this may sound to you like a terribly technocentric perspective. But our intention is actually the opposite, to broaden the concept of computation beyond silicon-based computers and examine the assumptions about representation and its historical contingencies. And a core assumption is about the importance of representation in symbolic computation. A digital computer gives us the numerical result and all the intermediary steps at all time, whereas an analog computer doesn't give us any numbers, embodies the phenomenon, and in order to get the result, we have to measure it. And Levmanovic's comment earlier made me about the brain being an analog computer, made me think about cybernetician Ross Ashby's statement that the brain is not a thinking machine, but a machine for acting. And maybe there are situations where we don't need to know the result, but we want to be able to act on it. And as I suggested in the introduction, the rich history of analog computers shows us different ways to think about computation in this way. And I think it looks like analog and hybrid computers will become more important in the future. There are areas such as microfluidics, synthetic biology, and quantum computing that go beyond the current digital paradigm. But I also want to point out that the role of this panel is not to further one particular argument, but rather show that there are many different viewpoints and that this is not a settled topic. It is a conversation that is worth having. And with this, I want to hand over to my colleague, Mikhail Kurtov. Thank you very much.
Спасибо, Дитмар. Здравствуйте еще раз. Спасибо, Дарья, за приглашение. Я рад видеть на сцене вместе со мной.
Thank you very much. It's such a pleasure indeed to be moderating this session, and I am happy to have Thomas and Ralf on the stage. I'm happy to welcome Theresa. I remember that 2 years ago, we were in Perm, and I talked about Theresa's work on mushrooms, I think, or fungi in any case. So as a philosopher, I am interested in metaphysical and technological underpinnings of art and science. What makes possible the kind of works that we see at New Elements as aesthetic phenomena? I believe that if not all of them, then at least most of them are rooted in something I would like to call the aesthetics of translation. Indeed, if we regard the exhibits by numerous artists participating in our current session called Material Computation, we'll see that something is getting interpreted, transformed, or resynthesized there. For example, Thomas Feuerstein's work called Poem, P-O-E-M. The air exhaled by visitors gets converted in chemical reactions into alcohol. And in Theresa Schubert's exhibit, Ooze, microalgae living in a bioreactor produce carbon monoxide, right? Which is registered by sensors and becomes a seed for generation of pseudo-random numbers. And then on this basis, visual images and sound landscapes get created. In Ralf Baecker's world called Soft Machine, manipulations with an alloy called galliumstone produce data, which is then used to synthesize sound. Naturally, these exhibits cannot be limited to translation only. However, systematic and productive application of this stuff is, in fact, a conceptual differentiator of arts and science from other elements or other fields of modern art. What is getting translated? Well, one physical or a chemical or biological phenomenon gets translated into another one. What makes it possible? In most cases, these are some computing digital machines. The digital is effectively becoming an intermediary, an interface between different, scales or fields of the nature. It's effectively a universal, ubiquitous translator of the natural, linking what was not linked before. And diversity of such connections or translations is seemingly unlimited, only bounded by the imagination of the artist. However, invention of computing technology is just one of the stage in the evolution of translation aesthetics. It was precipitated by a particular configuration of knowledge which made such translations possible. I'm talking about universal translatability. And this configuration of knowledge I call geographization of the spirit construed in the purely Hegelian terms. Gurgel, if you remember that, saw spirit as an ultimate abstraction of awareness, mind, culture, history, and society. History, according to Gurgel, ends when the spirit becomes aware of all the stages of its development. And what does it lead to, this so-called end of history? Successors of Gurgel, which obviously included Marx and Engels, in mid-19th century, try to wrap their minds around it. And this new condition I'm actually calling geographization of spirit. Spirit no longer travels in time, but rather in space. Not in events, but rather in things. Not in history, but rather in geography. Since motion in space, unlike motion in time, is reversible, it becomes possible to move the spirit from one spot to another, to translate it from one form to another. Translation is effectively a different name for this post-Gergelian geographized spirit. And although the translation function may appear formally trivial, and this is what Ludwig Feuerbach talked about, content-wise, it's extremely complicated. For example, 100 years ago, we couldn't even imagine that motion of algae or liquid metal would be sonified. Now, this trend actually leads its apogee by the end of the 20th century, when pretty much everything became translatable, although there were some issues when things were lost in translation. So the few remaining cases of untranslatability appear very interesting. Now, it may also seem trivial how to do translation in art and science. So why do artists continue to do it? Is it just a matter of habit? Is it simply inertia of their imagination? No, not really, or not necessarily. The thing is that any translation which is sort of complete, will have a luminescence effect, a kind of unseen flare around it, as if the spirit itself would flare in the moment of translation, sort of rejoicing at its newly found freedom. And spirit will be happy when it discovers it is freed of matter. It is no longer linked to processes or things. And this spirit, at least, postmodernist spirit, can be the algae and the sound, the air and alcohol. It is everywhere. The joy experienced by the spirit is effectively the joy experienced by the spectator, who actually sees that translatability is a kind of freedom. And the usual reaction is, who would have thought that? So the irony and mastery of artists in the field of art and science is primarily associated with their ability to create the right conditions for this unseen flair. And I believe the artists we have today have certainly achieved exactly that. See, I actually am wearing two hats here today. I'm one of the speakers and I'm also a moderator, and we have a plan according to which we are going to start our discussion. Each of the artists will have an opportunity for some short statements. We shall start with Ralf Baecker, who is going to tell us something about his work and maybe about himself. Sir, the floor is yours.
Thank you. May I get my slides on the screen before I start? Okay, maybe I start with a short introduction. My name is Ralf Baecker. I'm working as an artist since like 2005. I kind of started as a computer engineer or in computer engineering, but dropped out because I thought that is kind of boring. And I tried to look my aim was kind of to try to look beyond kind of the surfaces that contemporary technology produces. And this is kind of an early piece that it's called Rechnender Raum, Computing Space. I will not talk too much about the work that is in the show or that's going to perform later. I try to show a picture kind of the trip or my journey that I did since, I don't know, the last 15 years through the different modes or states of computing. And this is kind of based on the idea from Konrad Zuse, like a German computer inventor in the 30s and 40s, and he came up much later that the universe might be like a huge computational space, like the idea of digital physics, and that there's just information traveling and kind of changing the state of matter. And this is basically like a fully functional computational machine computing a cellular automaton, which is kind of related to these kind of practices or ideas of Konrad Zuse, but not exactly. And what you see is kind of a computational process. You can see every bit, how it's moved and how it's changing its state. And everything can compute, so computing does not mean, we heard it before, matter can compute. It's computing doesn't only mean like that it's happening in silicon or in tubes. You can make basically everything compute, you just have to design it in a way to create like distinct states in the material to imprint it. Maybe you can see the next picture, which is kind of like a zoom into it. Or can I, yeah. And so you see like, I mean, this is kind of like a hybrid between kind of 19th century thinking or 18th century thinking and kind of 20th century kind of computational thinking and kind of how to make a kind of a strange hybrid of these kind of ideas. Also influenced by the differential engine, the novel by skip that, I forgot the name. Maybe go to the next one. Further, I try to dive into computational ideas and kind of to leave like this traditional machine thinking of discrete states that that a machine kind of switches and runs through. And what you said is like really interesting, that the computer is translating between time and space and vice versa. That's basically what computational machines do. And this is a machine that's called the conversation, which is kind of like basically like a material or a model, or kind of the aim of kind of to enlarge kind of a complex, or to stage a complex system with very simple mechanical parts. So you see, if you go to the next slide, you see like 100 actors that can sense. Can you go to the next slide, please?
Следующий слайд переключите, пожалуйста.
You can see there are like 100 actors that kind of sense the tension in the system and try to react to it. And by this, they kind of they try to adapt to the tension in the system, kind of create like an infinite dialogue of elements that create kind of like an equilibrium, which is kind of related to Ross Ashby's idea of the homeostat, like a system that is a system that needs many players in kind of to create a state of order or a state of stability. Maybe go to the next slide, which is kind of a project kind of that takes this kinetic or electromagnetic and kinetic machineries. In this case, it's kind of also a system component of, 190 actors that kind of communicate through a mechanical coupling and kind of create a dynamic changing of an image, of a process. So I have really also a strong interest in aesthetics and how kind of can we, how to transform complex systems into, to enlarge them and to make them perceivable. And this system is kind of triggered by randomness. So there's like a set of Geiger tubes in the space distributed that pick up random radiation that kind of is fed in the system, and the randomness and their coupling kind of create a dynamic change of the shape. Maybe go to the next slide. You can see, yeah, you can skip that, you can go to the next one, just that you get an impression. This is also a piece that kind of meditates about computation, or what computation is. It's a system that consists of many actors that just do one thing. So it's like a bouncing. You see these white stripes, white sticks, they bounce, and when they hit each other, they reverse their direction. And it's basically like a deterministic system, because if you know the state of the system and you turn it on, you can theoretically kind of foresee kind of how the state will look like after a certain time. But somehow it behaves different, so it starts to crystallize in a way and create complex patterns and so on. And in a way, that's a practice that I was following for a while, like kind of taking conceptual ideas of systems, ideas of cybernetics, and kind of translating them in computational and into kinetic, large-scale objects. And if we go to the next slide, which kind of follows a different trajectory. So I was looking into the geological dimension of computation. This was informed by this Jussi Parikka, kind of the geology of media, and I discovered like this, the idea of geomancy, the deviation of the future through geological material, and this is kind of a memory, a computational machine that stores information in little stones. And the machine, which has a little camera, which has like a little push and pick and place mechanism to move the stones around, and it's kind of computing on that material. But the material is like really unstable, so it's always kind of prone to produce an error, or kind of it's integrating mistakes constantly into its process, and this is kind of like also a hybrid of, like, it's a Turing machine kind of thing, but also like a mystical thinking about how the geological material kind of is where like a deterministic future is kind of encoded into the material. You can go to the next one. Maybe that's just a zoom. You can see like the stones, and that's the next project, which was actually also exhibited in Moscow a couple of years ago, where I tried to dive into the material substances of contemporary technology. So, for instance, semiconducting materials and other things, that rare earth materials that we find in contemporary technology. And I imagined, or I speculated kind of what is, if I just take this raw minerals, specimens from nature and kind of put them in a contraption and kind of try to get them computing, but in a more like in another ration, without any propose, but to give them kind of an open space to operate. And if you go to the next slide, the piece was called Irrational Computing, which kind of consisted of many kind of little apparatuses that kind of used, where kind of contemporary circuits are kind of integrated into, or where raw minerals like galena or silicon carbide or quartz crystals and other things kind of integrated into circuits and kind of pushed in a mode of open, irrational, computational processes. Yeah, we can go to the next slide, probably. This is one zoom, like in one element, which is kind of the central part of that irrational computing installation, but also an individual machine, which is basically like a large rock of or specimen of silicon carbide, and the silicon carbide is kind of punctuated by many needles that create semiconducting transitions in the material. And the idea was like, okay, I take this raw material and kind of feed data into the geological material and see how that material responds and kind of involve this material in a very strange dialogue of my algorithmic thinking and kind of the material quality of that device. And the material itself kind of creates this emits light like an LED, so it's kind of also the basic material that you have in, well, not today anymore, but like the first LEDs were done with silicon carbide. And it also starts to vibrate through the electrical pulses, so it's kind of like an archaic kind of audiovisual kind of material. So that was the approach for that piece. And maybe go to the next one. There shouldn't be too many. That's a zoom, so you see how the crystal structure emits light. And next one, please.
Следующий слайд, пожалуйста.
Maybe it's the last one. No, it's another zoom. You see here is like the quartz crystals integrated in a resonating circuit, and there's like the galena crystals that kind of do logical operations. It's kind of like a diode logic mechanism. And then we go to the next one. Maybe it's also already the last, I'm not sure. Oh. But I think maybe it was the last. And but maybe one thing to close or to finish the presentation. So this is also like if you see what I do later today or the work in the exhibition. So it's kind of really different. So this goes from a very analytical, deconstructive mode of understanding media and kind of looking into the fundamental principles and kind of exposing them to make them perceivable. And now I'm kind of trying to find ways in my work kind of to use or to enable kind of the original kind of material qualities that are, or like Dietmar has also mentioned it before, like how every material itself has a computational quality, and how can I make them kind of talk, or how can I activate them? And this is also important for the piece later. So it's on one side it's like an audiovisual piece that has a highly aesthetic kind of effect, hopefully, but it's also like a long research into the work of Gordon Pask, who kind of proposed against the Turing machine kind of an analog computer that kind of needs like, that's kind of feeded with signals where kind of iron structures grow in a petri dish and kind of create like more like a neural network, would consider more like a neural network kind of a structure that it's kind of creates a resistance, a field of resistances in that petri dish that is analog to what it has perceived before from the outside. And yeah, that's what I'm interested in.
Спасибо, Ральф. И у нас есть немного времени для обмена репликами между участниками.
Thank you very much, Ralf. We should have enough time for Q&A. So if we have, questions from the room we'll take later. But let me ask you this one, because this question I will be asking to every panelist. This one is about your personal preference. Do you love any particular element or any particular material? There are different ways you can translate material. So Gaston Bachelard, a French philosopher who wrote a very large volume on psychoanalysis of the elements. So he talked about fire, water, earth and air, which have been helping philosophers imagine the splendor of this world, are in fact underpinnings of what philosophers do. And you may think that the impact of the elements on what they do is metaphoric and superficial, but it isn't. Sometimes you can actually see how very different, apparently, productions, poems or novels are actually based on the same kind of element. So Bachelard was actually interested in this relationship between elements and imagination. So if we can actually apportion, allocate an artist to a particular element, this will give us a key to understanding their art. In Ralph's, Theresa's, and Thomas's works, we are exposed to elements. In Ralph's works, I get an impression that you gravitate towards solids and maybe liquids. You do seem to like crystals, like silicon, for example. But the one you are presenting today is liquid metal. And Bachelard often said that, elements often go in pairs, like fire with water, solids with liquids. But they never come in trios. So take Gallinstan, for example, the alloy that Ralf has used in in that particular work. Well, we are dealing with both a liquid and a solid at the same time. That's why I actually asked for the chemical composition of Gallinstan, like, is it crystal in nature, is it amorphous, or is it a liquid? So this is, the thought behind my question to Rolf. So do you gravitate towards a particular element or not so much?
Honestly, not so much. I mean, I mentioned I started as a computer scientist, so I actually gravitate also to code and kind of the relation, how code is kind of imprinted on matter. How do we kind of use materials kind of to imprint information on it or to encode information in it. So it's kind of that in all the works, it has a material dimension, a very physical dimension, but it's all kind of connected to, or for me, kind of the code thinking and the digital thinking is kind of always kind of very present.
Ну, код, наверное, относится к воздушной стихии или к стихии эфира, к пятому элементу. Спасибо.
I'm guessing that code should be part of the air element or maybe ether. Dietmar or other participants, would you have any questions for Ralf right now?
No, I mean, I think we can definitely talk more about all of that in the following discussion. But I really like the way how Ralf also makes this point that it's not a particular element or a material that implies a certain computational paradigm, but that it's all a question of how you treat it. Like whether you are Norbert Wiener said, if you basically introduce this kind of a certain time of non-reality, or if you kind of disregard the temporality, you arrive in the digital universe with the same material. And I think this is what Ralph's work shows. So I'm curious, is this how you would also see it, Ralf?
Yeah, I mean that's I mentioned that in the beginning, but there's like this actually like this speculation that I'm interested in, like also with that I'm like with the current work with soft machine, that there's a speculative computational universe out there that can't be framed with that Norbert Wiener's, like a fluid system that where sure there's an enforcement from the outside on the material, but it's kind of unpredictable how it's behaves. So it's kind of just kind of work is much more complex than like this singular atomic logic units that I used to work with, where like this time of non-reality plays a big role, like this forcing materials in certain states, and but this is kind of like this fluidic systems are interesting to me because they kind of give me they are actually more efficient than the other systems in how they generate information or condense information and that's kind of what I find interesting in contrast of that paradigm from Norbert Wiener, yeah, or the forbidden grounds of Bigelow, John Bigelow, I think he called it the other word for it.
Спасибо, Диетмар. Ну, я думаю, что еще можно будет задать вопросы Ральфу. У нас еще довольно такой сжатый план.
Yes, thank you very much, Dietmar. We should have time for other questions to Ralf a bit later. And in the meanwhile, I would like to ask Theresa to tell us about her works. Maybe, a kind of a relatively short introduction, so that's, we have time for questions. Theresa, over to you.
Hi, thank you very much. I'm going to share some slides with you as well. Let me know if you can see them.
Пока нет, не видно.
Not yet.
Not yet?
Nothing, not. Yes.
No, we do.
Yeah, okay. First of all, I want to say how happy I am to be here on this panel because the topic of material computation in general has been a very fundamental question, not only for me as an artist, but also in my more theoretical research, also as part of my PhD thesis, actually. So it was very hard for me to decide what I will actually show you in these very few minutes that I have for this presentation. So like just as a beginning, in the last couple of years, the core question, let's say, that was at the foundation of my artworks was how can we use technologies or repurpose or reinvent them to create respectful relationships between ourselves and the planet, including non-human, biological, and artificial entities. So in my work, I'm usually trying to combine living organisms and new technologies, artificial materials, in order to deliver alternative sensory experiences, new ways of perception for visitors to the exhibition, with the aim to broaden the human-centered horizon and to deliver experiences toward an intelligent ecosystem at large or more than human conditions. Another question that I have investigated in detail is the question of agency, what agency actually is and what agency means in particular in artistic practice. When you work with living beings, what kind of agency do they have in an artistic work? But also in kind of in terms of artificial technologies, when you talk about artificial intelligence or algorithms, rules, what kind of agency evolves or emerges or maybe does not in these artistic practices, like my peers are also doing them. My work follows also or is very much founded in nature observation and material entanglements, following very much Karen Barad's performative practice, where she says that knowing does not come from standing at a distance and representing, but rather from a direct material engagement with the world. And Andrew Pickering has described this similarly when he says, performative dances of agencies and findings out are the way to understand about the complex system of our world. I very much liked for many years this quote from Stafford Beer, the cybernetician, and he brought up in the 60s the idea that there should be a completely new way to the construction of computing elements, finding some material with the appropriate liveliness rather than laboriously engineering that matter. And that was very influential for my practice, because I started to think, aside from like a standard silicon-based computer or electronics, what could I actually use? And I started, I started to work. Slides are a bit, yeah. So I started to work with slime molds and fungi, cultivated them in my studio, and trying to also understand how they were behaving, or whether they were possessing some kind of special behavior that I could use for an aesthetic outcome. And Mikhail, as you have mentioned before, we met a few years ago in Perm at the exhibition, A New State of the Living, where I was growing mushrooms and tattooing them, the ones that were ready at the beginning of the show, with the aim to observe over the duration of the exhibition how the tattooed geometries would change based on the natural process of the fungi membrane that kept expanding and growing over time, and how essentially this aesthetic process would be influenced by a living organism, in that case the fungi. Last year in spring, I started to go around Berlin and collect pond water here around the area, because well, that's also a little bit influenced or in reference by Stafford Beer's attempt of creating these pond factories, or where he was trying to create a pond ecosystem that would function as a homeostatic controller. Well, he didn't quite succeed with that, neither did I, but I was very happy to, a few months later, receive the invitation from Laboratoria for the commission of OOS, and I found this an ideal opportunity to keep continuing working with algae and combining it also with digital technologies. So I prepared only a couple of slides about this work, mainly for our visitors that are joining online on the stream and don't get the chance to actually see the artwork in reality. But what you can see is essentially in the center is this column made from 3 DIY algae bioreactors with 3 different species inside. And you could say, as a metaphor, that they act kind of as the brain of this installation, because their function is an instrument or an interface also for the visitors to interact with the species and influence aesthetic properties in the digital video projections in the background. So it's a work that's between observation, it's got a meditative character to it as well. It's material experimentation and also playful action by people allowing to use their mobile phones, for example, to shine light on the algae species. And the idea was to offer an algae-altered narration of specific aspects of our world. And specifically, I was investigating visual metaphors of networks, and in this sense, networks and infrastructures. So I was conceptually interested to interlink the forest as a hyperorganism, this huge kind of network and very important for our human survival on Earth, with the server farm as a metaphor for the underlying networks of our digital and carbon lives, because essentially every email, like our conference right now, everything goes through some server in the world, and the physical presence of this data that a lot of people still believe is just something in the air. Very many people forget about this, so I wanted to also give this a representation in this work. What you see on the projections are 3D laser scans of these two infrastructures, and in combination with the algae sensor data, they are kind of reconfigured, aesthetically changing specific color and temporal parameters, and also in terms of abstraction. So the algae introduce disturbances and unpredictable events in the setup, like it would also happen in real life. They are an organic entity, a biological sculpture. They live inside the installation and are connected via sensors to the outside world. It can also be understood as an analog random number generator, that it's driving parts of the video and the sounds in the exhibition. So the growth and the metabolism and the productivity of the organisms, they create uncontrolled events that are monitored by the sensors. They are a physical interface for the visitors by shining their cell phone lights onto the algae cultures, which will in long term contribute to, for them to grow better and produce more oxygen, which is then also afterwards released into the air of the museum space. So we also, people in the exhibition at the end, breathe the air that the algae has created. So this allows the visitor to feel interwoven into a world of computation where the digital and the natural dissolve into each other, but also where you can follow how humans leave presences or traces or noise in this system. On these slides, you can see a few photos from the development of these algae reactors. On the left, my home prototype, but also I was grateful that I could work at the Technical University of Berlin. They helped me or gave me space to also cultivate the microalgae, but also very grateful for the Moscow Institute of Plant Physiology that were actually cultivating the algae for me on site in Moscow, because obviously I couldn't bring liters and liters of algae species on the plane. So it was very important to also have this local collaborator and expertise here on site. I would like to end my short presentation and rather keep the time for the other presenters and the discussion and questions, ending with this last quote of mine that for many years, now I haven't used it for many years, but for many years it was in all of my presentations. It's from Michel Serres from 1995. And he says, if winds, currents, glaciers, volcanoes, etc. carry subtle messages that are so difficult to read that it takes us absolutely ages to decipher them, wouldn't it be appropriate to call them intelligent? How would it be if it turned out that we were only the slowest and least intelligent beings in the world? So I think the quote kind of, in a very smart and way, enables us to do this mind switch, or this switch of positions where we don't start from our human perceptions in the way that, well, our senses process the world, but trying to understand how would it actually be. Well, try to imagine you were a glacier. How would you see the world, or what would it mean to you? Or what kind of information processing would you actually deliver to us? So I keep it at that. And I'm looking forward to your questions. Thanks.
Спасибо большое. Ну, я очень рад тем, что ваш короткий рассказ закончился упоминанием книги Мишеля Серра.
So glad that you finished your speech by mentioning the book by Michel Serres. I do hope this book will be translated into Russian one day. I have a question for you, Theresa. I believe that any communication, any interaction between a human and non-human agent is always, if you like, a meeting, a kind of a singular situation where this non-human agent can be more or less talkative, can provide more data or less data. Now, if we look at your ooze, where this non-human agent obviously is the algae, I had the impression that the algae is not particularly talkative, and getting data from the algae is more difficult than getting data from the fungi, for example. What do you think about richness or poverty in terms of communication of various non-human agents? Because I understand you have a wealth of experience in this field. With what non-human agents was it easier to work in terms of ease of extracting information? Because, you know, with algae, you know, they are reading DGS. What is DGS, by the way? That's it. Thank you.
Well, in that sense, definitely, I would say it's easier to work with fungi or mycelium, also purely as a matter of scale, that it's easier to see with your eyes. So when you work with microalgae, I mean, in these kind of bioreactor environments, all you see is a very dense mass that is actually fairly homogeneous, at least if they're alive, which I hope. So at first sight, you can't see so much information unless you do employ sensors, electronics, to read that out. And then obviously it's a matter of how good the sensors are and how good the programming is behind it and how everything is connected in that way. And also the most important thing is to find the appropriate translation. And there, I think, is always a matter of experimentation and something that takes a lot of time, because failure, as all of the people that do work with living beings and biology especially know, failure is a big companion of our art practice. And in this particular work now for this new commission, we didn't have so much time to let's say, maybe tweak the system. Maybe for a new version that I would like to do, this looking back at the data that is now actually collected also. You could actually say maybe the exhibition is also an experiment, let's say, an ongoing experiment where the data is now collected to, for me, afterwards to evaluate and to understand what has been going on and go back and look at the code and the electronics and the species to understand what made sense and what didn't make sense. So now I'm getting lost and I could go on forever, but maybe that answered your question.
I'm sorry, there was a question about DGS.
Sorry, what?
I think that one of the things that got measured was DGS. What was that?
TDS. Yeah, that's the turbidity. Yeah, that's kind of like particle density, or
DTS.
If you would say it's how clean the water is. It measures electrical charge, like the sensor works in a way that it measures electrical charge in the water. So in kind of the more algae species you have, essentially, the higher this value gets.
Спасибо, очень интересно. Да, Dietmar.
Oh yeah. No. I just have a quick follow-up because you already started talking about, you know, the role of ephemerality and failure, and of course also death is part of all of, you know, every living being and the systems that you're working with. And my question would be like, how do you, in your kind of post-media art perspective on computation, how do you account for it? Because in the history of digital computers, the approach was always to create reliable outcomes from unreliable parts. This was this kind of mindset to use radio tubes and things that break very easily but still give you the right result. But I'm suspecting that the way how you look at failure and the role of biological death also in these experiments is a different one.
Yeah, I mean, the ethical question is always a very big one for everyone in the bioarts. So that's hard because I think you can't produce without at the end causing it. So you kind of need to find a way for yourself about, let's say, creating the most healthy survival environment you can for these species in your studio. But you cannot ever totally avoid it, I believe. But let's say returning fungi, let's say, into into compost or like the outside earth or whatever, so that at least you have the idea it contributes in a larger sense to going back to the earth or something is for me, let's say, respectful treatment, but also in general acknowledgement or that I'm happy these species at the end also want to work with me by surviving. But it's always, it's a hard one. But that's also the point where I usually work with organisms that are not like, let's say, like a pig or something, which is clearly very close to our the intelligence definition is very hard to say, but let's say it's closer to our understandings. We can clearly communicate, I would say, with dogs or other animals of that scale. So with these ones, I would have a hard time doing what I do.
Спасибо, да, это тоже интересный поинт. Может быть, у Томаса с Ральфом есть вопросы?
Yes, thank you very much. It's a very interesting point. I'm wondering if Thomas and Ralf have any questions to Theresa? Or not?
Have you anything to ask Theresa? Maybe, I don't know, because she's not the...
I think we would have many questions, but maybe later.
Okay. So мы переходим к Томасу Фeuersteinu.
Okay, then let's turn to Thomas Feuerstein, who is also here. Thomas, please tell us about your work.
Yeah, artists like not only to talk with words, also with images and processes. So like Ralf and Theresa, I brought some slides. And if it's possible, thank you very much. So I'm thankful, Mikhail and Dietmar, for the topic in this section, Computation with Nature, because it concerns my project not only in the digital terms, but also in material or molecular terms. And for this means art that operates with processes of entropy, neck entropy, chemical synthesis, and also biological metabolisms. And computare in Latin, or putare in Latin, in mathematics it means to calculate, but in general it means to bring something into order. And I think this is the meaning in nature. Nature calculates or computates with matter and molecules. So here we see the, next one please, the periodic table. And for me, it reminds to the keyboard of a typewriter or the keyboard of a computer. And of course, no one of us, also not artists, can create new elements, but art can maybe compute elements and bring them into a new meaningful context. So the basic meaning of elementum, it's interesting for me, I read it yesterday, means also a small part of language in the sense of a letter. So you see, we have a double connection of the periodic table and the elementum in the periodic table and the typewriter. So with this in mind, I wonder, is the periodic table the keyboard for the future thing world? I think we're just doing it. We are writing new molecules, new materials in the laboratory and in technology. And I bring you, the next one please. I show here an old charcoal drawing, and it shows a typewriter. It was the first serial-produced typewriter used by the philosopher Friedrich Nietzsche, and it shows, instead of alphabetical types, chemical elements. And I show you this because the carbon for this charcoaling I obtain from a chemical process. It's called hydrothermal carbonization. And the carbon comes from the carbon dioxide in our atmosphere, and it's done by green algae, like Theresa told us before. It's chlorella algae. I like chlorella algae very much. Chlorella in Greek means small green, and it's the maybe the oldest still living plant cell on our Earth, and it has the highest content of chlorophyll inside the cell. So the coal is produced in this sculpture by the chemical process, and I show you this dirty, quick drawing. The next one, please. In relation or in opposite to a very famous painting. Maybe see the next slide, please. Yeah. So on the left, you see the famous painting by René Magritte. And you find this inscription, "This is not a pipe." And the dirty, quick sketch, which I have done with a pipe, and I have burned the pipe, and with the ashes I did this sketch. So for me, these two images refer to two different paradigms, the linguistic turn and the material or metabolic turn. And this marks the change from symbols, and I call it, to metaphors. So art has always functions iconically and linguistically, but today materials, molecular and processual moments play a crucial role. So here we see, thank you. Here we see a map of metabolism, which is found in every cell of our body, in every plant cell, in every bacteria cell. And metabolism is, for me, the most complex form of computation with matter in nature. And maybe in daily life, on Earth, the most important metabolism is the so-called autotrophic metabolism in plant cell of photosynthesis. And I use photosynthesis or photoautotrophic processes in many of my projects. For me, it's a starting point to produce something with the help of light, and to start computations. They are more complex. For example, here I show you only very, very few projects. I use the metabolism of chlorella algae to produce a new molecule, together with the tyrosine, which the plant cell of chlorella is very rich, together with ingredients we find in mushrooms, psilocybin. I was lucky to find a chemist who was able to produce or to computate, I say, with a chemical synthesis, a new molecule, a molecule which not exists in nature, which not exists in industry, and I wanted that this new molecule, I call it ironically the smallest sculpture of the world, because a molecule you're not able to see, And I wanted that this small sculpture or molecule is related to art. So if you, here you see the pathway, the chemical pathway for the production. Here you see, you cannot see the molecule, but you can crystallize it like cocaine or whatever. And the point is, if you, it's not the need to see the molecule in the exhibition like a bronze sculpture. The point is you can transfer the smallest sculpture of the world into your body, you can swallow it, and you can exhibit it in your body and in your brain. And then it takes the effect of an interesting drug, so it has psychotropic effects. Yeah? And this is the relation to art, because we start to see our environment in a different way. And this is also a computation of matter, of elements to a new, completely new molecule. I call it sculpture because a sculpture is a three-dimensional form. And it's also a computation after I have swallowed the sculpture in my mind, in my brain. So the next one, please. Next one. Okay. So what we see here is related to the piece in the exhibition downstairs, New Elements. I did this piece in different versions. This was the very, very first version, and it shows only the old experiment by Stanley Miller, the so-called primordial soup experiment, which he did in the early 1950s. And I like this experiment very, very much, because for me it's okay, it's a science experiment. It asks, how is it possible that early life changed, or the start point of early life was the change of inorganic material into organic material? How is it possible that suddenly amino acids awake in a bound? And for this, and this is also linked to a mythological thing, yeah? You know, many of you are Orthodox Christians or Catholics or whatever, and so in the Genesis, but in the Genesis you have heard in school, in the beginning was the Word. And so then the lightning from God comes together with the Word, with the information, and creates life. Yeah? And here the information was not collected and analyzed by chromatography like Stanley Miller did it. Together with a friend, with a sound artist, we transferred this data into sound, into electronic music. And now here you see the next one, yes, the piece downstairs. So here it's more complicated. We have a second layer. It citates an experiment of the 1890s where scientists thought, oh, maybe it's the early life was not a primordial classic soup. Also Darwin thought about these things and speculated about these volcanic soups. No, it was maybe in the deep sea near so-called black smokers. And that was for me very interesting because near these black smokers we have chemical reactions which first produce ethanol and then ethanol, and this is alcohol. And so for me it was interesting to have not a reference only to science history and to methodological things of the Genesis. I would also have to do a context in the art system and what happens if people enter an exhibition space. They are talking about art, and physically talking about art means hot, warm, and wet air comes out of the mouth. Yeah? And in this installation here, the next one, we see a microphone, and this frozen microphone, the water, which comes out of the mouth, condenses and triggers the processes in the sculpture or in the machine. So if the people are very talkative, The machine can produce more water with the help of water, more amino acids and also alcohol. And if they drink the alcohol, you know, the people get more and more talkative, and the machine can also produce more and more drinks. So the drinks are for me molecular sculptures, yeah, and the installation is just a tool to produce molecular sculptures. Okay, I think we have to hurry up. So I produced totally about 72 different bottles with different labels, and the labels on the bottles are telling us a story. And you see one here, one of the first, which has the same title like the whole work, is poem. But this kind of poem is not written in words or letters, it's written in molecules, and that's the big difference, and that makes for me fine art or bio art so crucial today, so very, very specific. Okay, I think I come to, I finish and I say thank you, or I say cheers, yeah.
Тома, спасибо большое. Жалко, что мы не можем прямо сейчас попробовать результат работы вашего произведения, вот, который сейчас представлен на слайде.
It's a shame we cannot savor the results of this particular work, but I have a very short philosophical question to Thomas. This is something we discussed yesterday. Now, this question is about computability of nature in general. Like, we know from the history of thought and from the history of Western philosophy, there was a very important turning point. There was a very important junction. Now, Pythagoras said that everything could be computed, that everything is effectively a number. So we are still sort of following the route blazed by Pythagoras. But there were other philosophers at the same time who actually said, like, Anaximander would say that everything is air, and Heraclitus said that everything is air, and Thales would say that water is the primary element. So at least for ancient Greeks, these were confronting, so to speak, or in uncombinable ideas, so to speak. So they would have a quarrel over whether the world is a number or the world is air. And, if it's not a number, if it's air, then we probably shouldn't describe it in numbers. Then we should probably talk not in terms of quantity, but in terms of quality. And modern or Western physics states that we can actually compute the nature completely. And the way you're talking about your works and the way other artists are doing that gets me skeptical about that. Is it really true that we can, compute it so much? Maybe we need to develop qualitative, not quantitative formalisms to get there. What do you think about that, Thomas?
I think this is a very old dualism between the mind, the spirit, and the world of matter. And for me, interesting that you mentioned the old pre-Socratic philosophers, because they are not so typical for the history of philosophy, because they were really materialistic. So they called the prima materia arche. Arche are the very first things, so like architecture also, yeah, it's manipulating matter and building houses. Yep. And maybe today we are not manipulating, we are still manipulating matter to build houses, but we have already started to manipulate matter to produce completely new materials, completely new molecules. And in my art, I'm interested, I have no answers, by the way, yeah? But in my art, I'm interested to cross the border between the symbol science and the molecules and metabolism. So I like, and that's why I mentioned in my short speech, the distinction between the symbols and the metabols. So metabol is a term which not really exists, but I like it very much because this is going on in nature, in our cell, and with our technology, we start to handle this technology and to invent these technologies.
Спасибо. Очень хочется продолжить разговор на эту тему. У нас еще есть, спасибо, Томас.
Thank you so much, Thomas. I certainly want to continue this discussion, but we have one more participant, that's Ivana Abramovic. She's an expert in quantum physics, and I would love her to take the floor now. Ivana, the floor is yours.
Thank you very much. I have to start actually with saying that all three talks were really very inspiring. I have lots of questions and I'm looking forward to the discussion that will follow. I think out of the three, Ralph's work is most relatable to mine, but certainly all three touch upon very important points, also from the hardcore scientific point of view. But let me tell you a bit about what I do, and I will try as much as possible to also put it, let's say, in the context that the three speakers before were talking about. So I'm going to share a few slides with you. I hope you can see the slides now. Just.
Yes, we can.
Just trying to see if I can make it a slideshow, actually. Maybe that would be better. Well, I think it's also right like this. So Daria mentioned that I work as a quantum physicist at MIT. That's, well, it's almost true. It is quantum physics, but it's much more computational physics, in fact. And the project that I work on is called Spark. And I put a title here, Making a Star on Earth, just to spark your imagination a little bit. So the idea here of the entire project, of course, is to make this machine called a tokamak. I think people in the audience might be familiar with the term because it's actually a Russian invention. And it is a machine that aims to harness power in the same way like the stars do. So what we're really trying to do is we are trying to make an analog to a star in nature, but to make it here on Earth, which is very, very challenging for various reasons. But one theme that is common, I think, in all the works that we are talking about today is material transformation. And this is really at the core of this work. So the idea is to use the process of nuclear fusion, which basically means you have light chemical elements and they can go through a process in certain conditions where they actually form heavier ones. And it's actually the process by which all the elements of the periodic table that we've had the chance to see a minute ago are created. So by going further and further through the table, you're actually fusing lighter elements into heavier ones, and you're going along until you reach the end, and you really start creating new elements, as Thomas mentioned. Now, of course, you all know how a sun or a star looks like, but when we try to make an analog of that, then we try to make a tokamak, it looks very different, takes a very different form. This is a picture of a tokamak device currently operational. This one, I think, is in the UK, but there are many of those around the world, and many people work on these machines. And the material transformation that happens in these devices really begins with a gas of hydrogen isotopes, cerium and tritium. Tritium has to be produced in certain reactions, and it lives for certain period of time, and then it has a decay. But deuterium is an isotope that you can find in ocean water. It's very abundant. And in this machine, we actually heat a gas or a mixture of deuterium and tritium to very high temperatures, much higher actually than commonly found in many stars, because stars are very large objects of the universe. So the gravity of stars is very powerful, and it actually helps the process. Here on Earth, we don't have such gravitational fields and no means to artificially produce them. Of course, that would not really even be good if we could do it. Not sure that we would. So what we do, we use extremely high temperatures. And these temperatures are the order of 100, 150 million degrees Celsius. That is how hot this purple gas is that you can see on the right side of this picture in the machine. At that point, it's no longer a gas. It really goes through a transition, and it becomes something we call a plasma. So there we touch upon that theme of transformation of matter. So a plasma really is an ionized, let's say, fluid, which means that the gas is now so hot that the elements really are not chemical elements anymore, they're ions. So you have cores or nuclei of deuterium and tritium that are flying around in this machine, and you have electrons, and that mixture together is put in a very strong magnetic field, and those are charged particles that actually interact with each other, of course, but also you can interact with them by means of electromagnetic fields in different ways. Now, since the gas is heated to such extreme temperatures, there is no material that we know of that can withstand that, because the melting point of even the most heat-resistant metals is a few thousand degrees. I think 3,600 degrees is the largest melting point for tungsten. So we cannot use any material to contain the fuel and to sustain the fusion reaction. So what we do is we use an invisible, let's say, material. It's really a magnetic field, an extremely powerful magnetic field that has a very particular geometry, so that it closes in on itself. And if you could see the field, you would see that there's beautiful field lines that actually form an invisible bottle that holds this extremely hot gas or fluid, if you would. And in this setting, the fusion reaction can proceed, and it's really based on the quantum effect, the tunnel effect, which you may have heard of, which basically means there is something that is really impossible to happen, but somehow it still does. It's quite magical. And the heat, of course, and the kinetic energy of the particles that are in this fluid make it possible for the tunnel effect to take place. And in that fusion reaction, you release new particles, and you release a lot of heat. You release energy in the form of neutrons that then escape the machine, and then you can harness that energy. Now, these are very extreme conditions. So what happens if we zoom further into this problem is that we have very powerful processes going on, one of which is turbulence. So you can imagine, when you imagine a fluid, typically, or if you think of waves of the ocean or something like this, or even just a rain in your sink, you can see that fluids, very often, they can be turbulent. Now, these types of wild, very hot fluids, they get very turbulent. This is a problem for the whole concept, because turbulence really takes away the energy from the center of the reaction. And I'm going to show you, so this is, if you would be able to see the gas or the fluid plasma that is heated inside the machine, So you would see something like this. Now this is color coded for different reasons, but it's a simulation of the turbulence that happens inside such machines. I hope you will be able to see this nicely. Let me show you. So what you see here really is the plasma moving in different ways, captured or contained by the magnetic field. And such a process is extremely nonlinear. It's a very complex process. And plasma itself, being a fluid, being very hot and contained in a strong magnetic field, is a very complex system. So to model something like this, describe it, if you will, by equations, is very challenging. There are theories that can capture some, let's say, aspects of the, and they work in certain approximations, but usually this is not good enough if you want to routinely know what is happening and if you want to know when the onset of turbulence. So to relate this a bit to Ralf's work, the idea is really that we have a very complex system that we try to, let's say, simplify in the sense that we are looking for a few parameters or a few, let's say, evolution paths of the system that will tell us most of the information about the dynamics that we can expect. So it's really something that depends on many, many variables that we are trying to, say, project onto low-dimensional manifolds of just a few parameters, so that we can control them and so that we can better understand and predict what is going on. Now, of course, this is very challenging also computationally, and we rely on high-power computing. As you know, this is still silicon-based. But those are the most powerful computers are in use in science today. So to run a proper simulation of a process like this, it would take maybe a month to run, sometimes weeks, sometimes 2 months. It depends really on how demanding your input parameters are and how precise you want to try to the process. Now, there are also unknowns. So my work in particular is taking a different approach to this problem. Rather than trying to describe the process by using complicated equations, I'm trying to just use the observation. So just look at the process, measure what we can measure. And from these observations, that can be really also images or movies, very similar to the simulation you see here. So we can have cameras positioned in certain locations of the device so that we can actually record data, or we can have spectrometers and so on. Anyway, we collect data in different ways. And starting just from the observation and assuming that the process itself, well, it knows how it's going to evolve, of course, but we don't. So I try to devise algorithms and to use algorithms for machine learning and deep learning to discover the equations directly from the data, assuming that will work. That would allow us to actually probe new physics and to discover maybe some aspects of the system that we weren't previously aware of, that we couldn't capture. And we could also actually compare the theories that we already have. Now, just to give you a feel of how these equations that we are hunting for look like, I will just show you two equations that are the most simple equations that describe basic turbulence in such a dot. Now, I'm not sure how much you're used to looking at equations, but trust me, these are very ugly. Even if you have a PhD in math or physics, these are coupled partial differential equations. There's complicated things going on. There's time dependence and so on. So these are not easy to find, and this is really the simplest example. So this is really what I do. So this is what I wanted to share with you today. But I'm also very much looking forward to going back to a few points that the speakers mentioned, and also the last question that was about quantitative versus qualitative use or description of nature through mathematics. I think this is really a very important point, because there is, at least from a scientific point of view, there is a limit of how well you can describe something. And I think it's worth going back to considering, is it really descriptive what we should be going for, or maybe we should think about mathematics that is more closer to what nature does and how nature computes and how nature really generates these phenomena that we study and that we try to describe.
Спасибо, Ивана. Я рад, что вы
Thank you so much, Ivana. I'm glad that you decided to jump on the bandwagon of those discussing computability. And what you've just said tells me that, well, we need to continue dancing with this question. Apparently, there are still too many unknowns there. And it's also very pleasant to hear people from the other part of the pond talk about Soviet science and, you know, where it has gone now. We have about 10 minutes left, and I would love to use this time to ask questions to Ivana, the other artists, and Dietmar. And we must be getting questions online as well, but somehow I'm not getting them where I am right now. So do we have questions to Thomas, Ralf, Theresa, and others?
Yeah, I think Theresa has a question. Theresa, do you want to speak up?
I actually wanted to say something in regards to Ralf's presentation that popped into my mind. I made a note about your work where you talk. I don't know whether you mentioned the title, but one has the white bars and then they move like this sculpture. And you were mentioning essentially you could compute, if you knew the initial state, after a while, the pattern that would evolve based on this rule. I was just wondering whether you ever tried to compare this analog physical computation machine with a digital simulation, just to see whether the digital computation would maybe after a while evolve or emerge into something different than the physicality. If that makes sense.
I don't know, the microphone. Yeah, yes, I did actually. So I have a full simulation on my machine, and it's kind of consistent over time with the same starting values. But within the physical implementation, there's friction in the motors. There's kind of, I don't know, unpredictable kind of things that happen with a material dimension. So there's kind of more kind of chance or randomness or uncomputable kind of things in the physical implementation if I compare it to the digital one. Yeah, and it makes it more interesting. So that also kind of introduces interesting behaviors that are not in the simulation, but in the physical implementation.
Yeah, thanks. I guess that's why it's so interesting to work with real physical materials, because, well, the complexity is actually higher. You have more of these unpredictable factors and elements in it that, well, bring noise or these frictions into the system.
Спасибо, Тереза. Был вопрос где-то, да? Или из зала? Ага, пожалуйста, вопрос из зала.
Was there a question to Theresa? No, we've been hearing a lot about human non-human interaction, like talking to the algae. I'm wondering if we can actually call it a dialogue. If like we know exactly, you know, how much carbon dioxide will be released and how dark or dense this algae will become. You know, when you pretty much know all the details of the system, because, you know, in my book, a dialogue is when you don't really know what the other person is going to do or to say, when there is a degree of unpredictability. What's your take on that? Would you like to?
Yeah. Well, I think that is rather maybe a matter of interpretation, whether you would want to call it dialogue. As it is now, I would say I don't have enough information or understanding of the species actually to really talk to them or to understand what they want from me. In essence, I think that would require more observation and collaboration, if you want to call it like that, work with these species. I mean, in terms of this, like, let's say, post-human aspect, already the willingness of the visitor or the people trying to look at them and observe them and trying to somehow engage with them is for me like the first step into this direction. But maybe, who knows, maybe it can become a dialogue at one point.
Спасибо. И вот я вижу один вопрос онлайн, простой вопрос, мне нравятся простые вопросы. На какое определение вы...
I think I see one simple question online. It comes from Anastasia Gorshunova. What kind of definition of computation are we using right now? Can any of the participants provide their definition of computation? Just to make sure I understand what this, you know, analog computation or material computation is. Anybody? Can anybody provide a short and sweet definition of computation? Like, obviously, we're not talking about computation which happens on computers only. Does it require mathematics or not?
I have already done, so it's on you. I don't know, you also had a good definition like this, translating time into space and space into time. That's a good definition, I would say.
Да, интересно.
And I have a good quote from Gregory Bateson, who says, you know, about unpredictability. So if you kick a stone, then we exactly know where the stone can land, so we can compute it. But if we kick a dog, then we don't know.
То есть вычисление — это измерение предсказуемости поведения. Ну, я думаю, что это рабочее определение. Есть ли еще вопросы в зале?
Yeah. I think there should be a working definition for sure. And okay, when people say that, you know, chances are, you know, maybe, you know, I'm not getting the signal. Like maybe the algae is telling me something, but I'm not listening to the right kind of signals. And I'm wondering if, I'm sorry, and I'm wondering if by saying that, you know, we kind of say goodbye to the scientific view of the world if we're imagining communication channels where they have not been registered before. It could be a matter of interpretation for all I know. But if you agree with that statement, you are welcome to respond. Theresa, would you like to?
I kind of agree with this, so I don't want to add too much more in this. It's always, yeah, the difficulty in finding out, yeah, the channel in which to communicate in. And we already know how difficult it is for humans to communicate to each other, although we do process languages, clear codes to talk, and it's still difficult to understand. So it's much more difficult to talk to people where we don't even know maybe which language in an abstract sense they possess or developed.
Спасибо. Есть еще пару минут на вопросы из зала или... Ивана было, да? Ivana, please.
Ivana, please shoot.
I think it's a very interesting question, Theresa, that you just got, because in my opinion, really finding a new channel of communication with the environment, that's exactly how scientific discoveries are actually made. I think it's, and I think also it goes back to what you said in the talk, that you wanted to give a place to this, let's say, embodiment of a server in your work, and I think that's also very, very crucial for the understanding of technology, because I feel when I talk to people, especially, that they have a view of theoretical science that actually is not very accurate, because it's much more creative and a lot less exact than one might think looking from a distance. But when you engage with these materials that you're working with, and you look into how to communicate with nature in this direct way, I think it's really the right approach. And I think it would be great if people would, in general, try to find these links, at least with the technologies that they're using, because that's how you understand the world around you. And at the moment, I feel at least the digital world is really invisible to people who are not more educated in the sciences, but rather in social sciences or something of that sort. So I really like your talk and the work.
Thank you very much. I feel honored to hear this. And yeah, I agree also. Maybe there are more questions in a different direction that want some time, a little time we have left.
Спасибо, Ивана, спасибо, Тереза. Мы, к сожалению, вынуждены на этом завершать.
Thank you very much, Ivana. Thank you very much, Teresa. I'm afraid we'll need to start wrapping up because we're looking to a performance by Ralf Baecker. So please join us there. And if you have not been able to ask your questions, you can at least ask them to, well, if you have questions to Thomas and Ralf, they are still here. When are we going to have it? Okay, the performance will be in 30 minutes time. So please be back in 30 minutes, okay? Thank you very much, Thomas. Thank you very much, Ralf. Thank you, Teresa, Ivana, and Dietmar. It's been a pleasure.